So today I'm really pleased to introduce our session, Build AI-Powered Search for Every Data Source with Fivetran and Milvus. And it's an honor to invite our guest speaker, Abhijit from Fivetran, who was a hero behind this integration. Welcome, Abhijit.
Yeah, thank you so much for having me, Jiang.
Yeah. So I will do a very quick introduction of Milvus, and then I will hand it to you, Abhijit, and it will be your stage.
Sounds good.
All right. So my name is Jiang. I'm leading the ecosystem and developer relations. That's why I worked closely with Fivetran on this integration. So we started the open source vector database project called Milvus because there was a shift in the whole search and data paradigm. So in the past 2 decades, search was mostly about keyword mapping. However, this is very limited because it doesn't really account for the semantic and the essence behind the meaning of the natural language and the keyword that compose it. For example, if you can't really use keyword search for image search, and sometimes it doesn't account for things that looks very differently but actually carry the same semantic, or information carried from the visual content like charts or like menus, and even the words that shows up on them. So this is very limited, and thanks to the advancement in neural network and deep learning, so now we have the great tool called the embedding model, which can extract the essence from images and text and any other modality, so that we can use the output of the embedding model, which is a vector, to represent the semantic behind any unstructured data. And this is very useful because unstructured data nowadays, it accounts for more and more portion of the growing data in the world. And we have over 80% of the newly generated data in 2025 that will be unstructured data. So it's very important for us to have a systematic and efficient way to process and comprehend and leverage the unstructured data for all kinds of AI applications. So Milvus was designed with this background and mindset. We want to empower developers to build highly efficient and scalable vector search, which powers their retrieval-augmented generation application or image search or product recommendations. And we designed Milvus to be fully distributed cloud-native architecture so that it can store, index, and manage and use the massive number of embedding vectors generated by all kinds of workload. And we can empower developers to focus only on their business logic rather than worry a lot about the infrastructures behind this. So right now, Milvus is very fortunate to have over 29K stars on GitHub and over 66 million Docker pulls. Thanks a lot for the great research work and all those awesome engineers behind this project. Milvus now carries the most high performance and scalable vector search engine, and we have published a few papers on top tier database conferences like VLDB, sharing about the journey, sharing about the technology that we have developed behind Milvus, and also share the takeaways, how to construct a high-performance and scalable vector search system. And because there is a growing adoption of vector search in all kinds of industries and verticals, so that Milvus has been used by thousands of enterprises and developers in their use cases. So here is just an example of some. And Milvus is so great and loved by the developers because it was designed in as a purpose-built vector database rather than just adding a plugin to a traditional database. So that this makes it 3 times faster and cheaper than the other pluggable vector search library And also thanks to some careful design on the storage system so that it has tiered storage, it can put the data, only the most important and useful data in the like expensive storage like memory, and then it use the vector index structure or like memory mapping to leave the data not frequently accessed to the other cheaper storage. And Milvus is also cloud native and Kubernetes native. So we actually support different deployment modes. One of them is Kubernetes, which can easily scale to tens of billions of vectors. And then Milvus, of course, is vector native. It's designed for this vector search use cases. But just in addition to this, it also supports a lot of use cases and features other than vector search, so that it will be convenient to use this in your real-world application. For example, Milvus supports hybrid search with sparse and dense vector. It supports dynamic schema, where you can directly store a JSON inside. It has the great security and privacy features like RBAC and access control and encryption of data. It also has convenient tools to do say bulk data import. But today we're going to talk more about how to import data and extract data in a streaming fashion, and that's where Fivetran can play a very critical role. And Milvus can be deployed in various shapes. We have Milvus Lite, which is great for local experiment and prototyping. It can be used in your laptop or notebook by simply just pip install. We also have Milvus on Docker, so that if you have a lightweight, small production deployment and you don't want to get touch into Kubernetes, you can use Docker deployment. Of course, we have the Kubernetes and cloud deployment on Zillis Cloud, which is the most performant and scalable option of Milvus. And all of these options, they work with the same client-side code, so that on the client side, you don't need to develop another piece of business logic just because you have changed the shape of the deployment. You just simply need to substitute the network endpoint from the old deployment to the new deployment. So that makes it very convenient to migrate things from different stages of the application development lifecycle. And the well, I will have to say that right now the most popular use case of vector search is retrieval-augmented generation, and that's also a central topic of today. As you may have seen this before, the retrieval-augmented generation usually consists of two parts. One is the on the bottom, that's the offline indexing, where you have all kinds of unstructured data residing in your databases, business apps, data warehouses, and you want to leverage them by generating vector embedding from the deep neural network. And once you have the vectors, you can import and store them in the vector database for efficient search. And on the top, that's the serving stack. That's the serving workflow, where a user may ask some questions, and then you use the same embedding model that you used for offline indexing to generate vector embedding of the search query. And then with the search query, with the search vector, you can do a search on vector database. So that will give you semantically similar content. And with this content, you can prepare your prompt by filling in the context and the user question. And the large language model can do a much better grounded generation out of this and give you the reliable answer. While this may seem simple, but there's a lot of heavy lifting in the offline indexing part. About, say, how do I extract the data from various data sources? How do I reliably move them from one data source to another one vector database? And how do I do the streamlined vector embedding generation from this process? So there's a lot of technical challenges where Fivetran can provide a lot of value. So that Fivetran connects to over 500 data sources, like including all of the business apps and data sources and data warehouses. And they can be imported into Fivetran, and Fivetran can automatically move this in a streaming fashion. And now today, with the integration between Fivetran and Milvus, all of the data can be ported to the vector database destination. And in addition to this, this solution can also streamline the vector embedding generation so that you don't need to implement business logic to handle this and account for the failures or retries. Well, without further ado, let's welcome Abhijit from Fivetran to give us a more deep dive overview of a more detailed overview of this, and then deep dive into the technology behind this. And at the last, we'll have a live demo showing how to build a search for GitHub issues with Fivetran and Milvus.
Thank you so much, Jiang. Love the introduction. Also very interesting to see, all the cool and amazing things Milvus does. I feel like just through my experience of building the integration, I only saw like one thin layer of Milvus, which is just how Milvus stores data. But it's like so interesting to see there's like a lot more under the hood that just makes it so feature complete, for retrieval and usage. So awesome. glad that we did that introduction. So nice to meet all of you here. My name is Abhijit. I am a staff R&D engineer here at Fivetran. And today, as Jiang said, I'll be talking about AI-powered search, which we've enabled recently through the integration between Milvus and Fivetran, built using Fivetran's partner SDK. Just some brief details about me. I've been at Fivetran for about 5 years now, on and off. I work in the CTO's office as part of the research and development team. And well, my work in the CTO's office is mostly involved in building RAG applications internally to help our internal teams, our support agents, our HR teams, and our sales teams be able to find knowledge very easily that they need for their day-to-day jobs. Today I'll be talking about, what is Fivetran, why a good data architecture is important for you to build your RAG app, how Milvus can now connect to Fivetran, and also just a demo on, how you can build a search or a RAG application yourself on business data using Fivetran, Milvus, and any other tool. So Fivetran is an automated data movement company. What we do is we move data from point A to point B. It's as simple as that. Well, why do you need Fivetran? Most of the companies that are trying to, do business analytics, trying to build dashboards or build reports, or even training machine learning models, training AI models, and now more recently building RAG applications. You first have to get all of your data from different source storages into a central storage layer. Usually the sources are different business applications, few of the examples Jiang mentioned earlier, like Salesforce and HubSpot, things like that. GitHub is one example we'll be using in today's demo. Your data could exist in other places too, like files like PDFs or Google Docs and Google Drive. It could exist in operational databases like Postgres or MySQL. It could exist in like event streams, like Kafka. And also it could just exist in warehouses themselves as well, like Snowflake and BigQuery. And usually the destination where you want to put all of this data, where you want to centralize all of this data before you can, build your BI or AI model downstream is usually a data warehouse or a data lake. A data warehouse is more apt if you're doing business analytics. Data lake is more apt if you're using machine learning and AI application building. And now more recently, we support vector databases as a destination too. Zillus is the first dedicated vector database that Fivetran supports as a destination, which means that you can very readily using Fivetran build semantic search and RAG applications downstream. In case you've already heard of Fivetran, I won't be surprised. We've been here for a while now. We started off in 2012. We got established a few years later, and since then we've done a whole bunch of cool stuff. We've added a bunch of connectors, bunch of source connectors. We've added a bunch of different destination supports. We've also added in multiple strategies to allow you to get the data from these sources into the destination. I think in November last year, we crossed the 400 mark, and then very quickly, earlier this year, we crossed the 500 mark on the number of connectors we support. And one of the things we launched late last year was the Partner SDK. And the Partner SDK is what enabled this entire integration with Milvus to happen. So the Partner SDK lets customers or partners of Fivetran come to Fivetran and build their own connectors using our gRPC interface. And that's what Zillus did. Zillus built a Milvus connector that maps, Milvus update operations or create tables or create collections and create indices operations very closely to the relational operations that Fivetran usually spits out data in. So using this gRPC interface, Milvus was successfully able to create a Milvus destination for Fivetran. And most of the topic that I'll be talking about is how you need a good data architecture for building a good RAG application. And maybe you've heard this term floating around, shit data, shit AI. It becomes very true when you start dealing with like enterprise level workloads where you have huge volumes of data that you need to start maintaining and feeding into a RAG app. And you also have to keep your downstream application in sync with the source application. Because the changes in the source could be very fast, and you now have to propagate not just the data, but also the changes to the downstream application so that your downstream chatbot or copilot or whatever you're building is up to date with all the knowledge it needs to maintain. In the beginning of this year, I was working on a project where I was trying to build an automation for our customer facing support form. So this is what the support looks like on the Fivetran dashboard. In case you've not seen Fivetran before, on the left is how our dashboard looks like. You have a bunch of connectors that you can set up. You have transformations. You can register to Fivetran that go and modify the data or model the data based on your requirements. In case you face any issue with our connectors or transformations, you can click on the small chat icon that's on the bottom right corner that pops up a chat window for you. So right now, this chat is completely manned. There's a support or sales agent sitting behind it from Fivetran trying to answer questions for different customers. And what this means is that our support process is not as fast as it can be. There's also some downtime, when our support agents are asleep and customers are working from a different time zone. And we're trying to see how we can help our support agents become more efficient by just giving them better tools to be able to easily search across the breadth of knowledge Fivetran contains. And this is especially important for Fivetran because the breadth of connectors Fivetran has is so large that it is like humanly impossible for one single agent to be an expert in all of these different connectors or source and destination integrations that we support. So most of our knowledge is present in these applications that you can see on the left. It's present in chat applications like Slack, which contains internal communication, or Zendesk and Salesforce, which contain communication between Fivetran employees and externally. Or even Height. Height is like a project management tool where engineers communicate with other departments like product and sales and support. We also have internal wikis and technical design documents and architecture diagrams and things like that present in Google Docs and Slab. And also we have our own public website, fivetran.com/docs, that contains a lot of the troubleshooting steps that are public facing. And also GitHub contains all of our code and of the issues and pull requests and things like that that explain different issues they came up and also contain details about resolutions to different issues. So all of this knowledge needs to be easily searchable by our support agents to quickly be able to find an answer and respond to the customer. And by doing this, our support workflow becomes so much more efficient and reduces the amount of downtime that is there, or the time to respond to the customer becomes like far less than it originally was. And in this process, I was building this application internally. I was also evaluating a few companies externally who were solving the same problem, building a RAG app that can ingest multiple data sources. And in these discussions, we found out that most of these companies that were building these applications, they looked like this when you took a peek under the hood. You know, they have a Pringles can trying to run the car. It's pretty brittle. It's pretty broken. It can get the car running, but it's not going to run for long. The problem is that keeping up with the data, the volume, keeping up with the changes, trying to unify the data model from different sources, making sure that you have idempotency in the data movement, and also figuring out like your infrastructure, right, for moving the data. All of these are very hard challenges once you start dealing with data at scale that end up, requiring you to just like hire huge engineering teams to solve those problems, solve the big data movement problem. But these companies that are building these AI applications, well, they aren't like skilled data engineers who are just accustomed to building solutions for this, which means that they want to be able to spend more time downstream building the AI stuff, actually using, GPT or PyTorch or, those tools downstream, building very good applications and not have to care too much about like the acquisition of the data, because that is the downstream, solving the AI problem is the really hard problem, and getting the data isn't really that hard. It's just very tiresome to do. There's a lot of effort that needs to go into it. And most of these applications, they have architecture, as I'm showing you here on the screen, the bunch of sources where the data originally lives. You need to get the data of those places, centralize it into a data warehouse or a data lake. And then once it's there, you can do your, cleaning, your pre-processing, any sort of transformations. For RAG applications, these are specifically concatenating and chunking. I think those are the most common operations you perform to be able to do RAG. And once you've transformed your data, once you've built your data model that's appropriate for your application, you can then move the data into a dedicated vector store. You'll have to vectorize your data in between using, some embedding model provider, or, you can download your own open source embedding model and do it yourself. But you have to generate the vectors before it ends up in a vector store like Milvus or hosted Milvus like Zillis. And once it's there, well, that's it. You have your data in the storage layer that you need it to be in, and you can then perform, search or RAG or analytics as well downstream of it. And that is like the core problem that all the companies that need to spend their effort solving. So, the Milvus destination connector that we built using the Fivetran partner SDK enables this entire architecture, and it makes it very easy for you to set up this architecture yourself with just a few clicks. Just diving into a little more details, what are the different tools that you would need to use to set this up? So you have your data sources in different places. You would first need to get this data out of these sources into a data repository, and you can use a data movement tool like Fivetran to extract the data and then load it into your warehouse or your data lake. Fivetran supports multiple data warehouses like Snowflake, BigQuery, Redshift, Databricks as well. And then we also support open table format data lakes. So if you don't want to use one of these managed data warehouses, you can just bring like an AWS account or Azure account, and we can still land tables in an open table format in these data lakes. Once this data is present in your data repository or your data platform, you can then trigger transformations on top of it. You can just use like Python scripts, you can run SQL, or you can use frameworks and tools like Coalesce and dbt to help you easily build those transformations. And once you've gotten your data model ready, well, the next step is moving it into the vector database, right? Vectorizing your data using an embedding service like OpenAI or Cohere, and then moving it into the vector database. The problem is that, all of the companies we've evaluated, well, it's like, well, the second part of it is sort of duct taped together. They've hacked different pieces to make it happen, which makes it very brittle. So it's like, it's going to get you through the POC phase, but to actually make your application production ready, you're going to end up having to hire a huge engineering team to just solve that one small piece of the puzzle. Luckily for us, we have the destination connector now. built using the partner SDK that automatically extracts the data from the data repository, vectorizes it in flight, and then puts it into the vector database, Milvus or hosted Milvus on Zillus. It puts it automatically. And all you have to do to set this pipeline up is just a few clicks. You go to Fivetran dashboard, you click, here, 2, 3 buttons, and then that's it. You now have a pipeline that's going to be extracting your data and then keeping your vector database in sync with your source application. So yeah, that's it. That's all you need to build a semantic search application end to end. If you want to take it one step forward, as in the architecture that Jiang mentioned, you can build RAG applications too. RAG helps you search across the information in a more human-like format, where an LLM, well, it reads the documents that are relevant and then it sort of processes it. It reasons around the data that's present. It tries to correlate it with the question and then provides a more human-like response to the end user. So this is the architecture that works best for different companies. And now we have 2 connectors and different tools in between that are connected end to end to enable this process seamlessly for different businesses. And for the rest of this webinar, I'll be focusing on presenting a demo application built using this architecture. And I'll be choosing just one of each type of tool to enable this application. So for the source, I chose GitHub. GitHub, is the code management and code collaboration tool that many companies use. And GitHub also contains, apart from just the code, it contains some artifacts that help users collaborate, issues that represent information about what's going wrong with the code or questions just people have or features they want from your product. And, issues allow issue comments to be created, which means that different users can engage in conversation right on the code collaboration tool. So we're going to use GitHub as the source for this example that helps, you answer questions about your answers different questions about your product, just from a more technical perspective. So first step, we set up a Fivetran connector to get the data out of GitHub, put it into Snowflake. Fivetran is going to land the data in its raw form in a bunch of relational tables. For this demo, we're going to be focusing on specific tables around the issue entity. So like, comments for different issues, the assignees for different issues, different tags added to the issue, and, just which repository the issue belongs to, right? This information. We won't go into other things like the GitHub wiki or the code, and also, the pull requests and other things like that. We'll just focus on issues to just make this demo simple. So once you have the raw tables in Snowflake, you can use a data transformation tool like dbt to data model this, concatenate all the relevant information, do the join across this data, and then build a flat table that then can be searched upon. A flat table is one of the requirements for building a search application, because usually you want to build your vectors, and one vector would correspond to each row. And that is also the, hard, concretely defined input format for vector databases like, Milvus. So the dbt transformation helps you get your table into this form. And once it's in that form, you can then use the second stage connector built using the partner SDK to get this data into Milvus or Zillus. In flight, currently this connector supports using OpenAI's embedding service. We do have plans to expand this offering further to more embedding service as the demand grows. But for now, I think most of the customers, well, they're okay with using just OpenAI's embedding service because, well, so far, from our experience, they have pretty good quality. And also, it isn't that expensive in figuring out how to host models yourself. They give you like an API to easily embed data. So once you set up, the 2 Fivetran pipelines and the dbt model in Snowflake, you're good to go. You have all of your data then in Milvus. And for this example, again, I'll be using hosted Milvus on Zillus because it just makes it very simple for me to manage the vector database and also demonstrate its capabilities. But as Jiang mentioned, you can host Milvus in multiple different ways, whatever is appropriate for your business use case. And at the end, to just demonstrate the search capabilities, I built a very simple chat application that uses the semantic search backend to produce answers. We won't be building this chat application during this demo, but this is just to show you what you could be doing once you have an end-to-end semantic search solution set up. There are 5 steps to get you this system up and running. First, go to Fivetran account, set up a Snowflake destination. It's just 3 steps. You click on add destination, you create a Snowflake connector, and then you plug in your credentials. You then create a GitHub to Snowflake connector, where you click on add connector, and then you plug in your credentials again. You may be pointed to specific repositories if you don't want it to pull in all your data. And then once that's done, the third step is the dbt transformation. This again just requires some configuration. You plug in your credentials and you also point it to the GitHub repository where your dbt model is written and stored. I will go into a little more details about this later in the live demo, and I'll show you, what the models look like. But once you have, your Snowflake destination, your connector, and your dbt set up, then you're ready to set up a second stage pipeline. So then you can go and create a Milvus destination. Again, as simple as it was before, you just come to Fivetran, you click on add destination, plug in your credentials, and you're good to go. So you now have 2 destinations. You have one connector, you set up the other connector, the second stage connector that extracts, vectorizes, and loads data in flight. And again, come to Fivetran, click on add connector, plug in your credentials for the source, and boom, you're good to go. So 5 different configuration steps is all you need to get your system running end to end. You don't need to, write a lot of code. The only place you would probably need to do custom configurations is in the dbt step, where you have to model your data appropriately for your business application. But what this system helps you is it takes away the need for you to, write your code to wrap around the source API, the GitHub's REST API or the webhook API or the Milvus gRPC interface. You don't need to program all of that anymore. All of that becomes standardized, and you focus more on just data modeling your data for your downstream application. So yeah, I'll switch to a live demo now. Just showing you, the different screens I presented. One of the things I did beforehand, just to save time during the webinar, is I set up some of these connectors already and got them syncing so that, we don't spend too much time doing the setup information, the setup configuration here. So this is the Fivetran dashboard. And as you can see, I have 2 connectors set up. The first connector is syncing data from GitHub to Snowflake. And the second connector is syncing from Snowflake to Zillus. Again, in case you're curious how you can set this up yourself, you can just click on add connector, go here, choose the type of source you want. So let's say GitHub, and then, click on setup, and plug in your credentials here. I'm not going to do this again because I already have the connector set up. And to set up a destination, you could just go to destinations on the left side, click on add destination, or here you have, our whole list of destinations, and you'll see that Milvus is available, is currently in preview. So you can go and set up a Milvus destination. You have to name your destination first. So let's call it test destination. And or here you just have to plug in your credentials. My internet might be a little bit slow today, so this might take a few seconds to show up. But it's, as simple as it is with setting up the other parts of the system, which is you come here, you plug in your credentials. One of the extra things you need to provide to this destination comparing to other destinations is that you need an OpenAI token. And that's pretty much because currently we only support OpenAI as the embedding service to generate the vectors in flight. But maybe in over time, this could be expanded to other models too that can run locally as well. And this connector says Milvus, but you can use Milvus deployed anywhere. And Milvus can be deployed locally, it could be deployed on Kubernetes. You can also be using a hosted Milvus on Zillus. So you can just come here and put in your Zillus URL, your Zillus API key, and then your OpenAI token, and you should be good to go. You can then go, you have a connector set up. So I have these two connectors currently syncing. The GitHub connector constantly fetches data from GitHub source. Anytime there's an update to the source application, it's going to pull the data into the downstream application. Oh, by the way, for this example, I am using one of the open source repositories called Tauhi. So Tauhi is open source machine learning framework that lets you process and encode unstructured data very seamlessly. And this is completely open source, which is why I chose to use this for the example application. It has a bunch of issues. It looks like there are 5 open issues and then, a bunch of closed issues, each of them having conversations talking about, different exceptions that customers or, users came across, or different features users want, and then some labels assigned to it, what the issue can appropriately be tagged as, and also conversations on the issues, providing resolutions or providing updates on the issue. So once you have the Fivetran connector set up, syncing from GitHub to Snowflake, you should be able to see the data in your Snowflake account immediately. So as you can see here, each sync takes around 35 seconds, and these are incremental syncs. So your first sync might take a few minutes, but then your incremental syncs, they're very short, they're very fast, and they only pull the data that was updated since the last sync into your warehouse, and they patch the data in the warehouse. So since I have this connector set up, I can go to Snowflake, go to my data, and in my database, I can go and see that, oh yeah, my tables are present. I have all of the different tables that I can extract from GitHub. And for this, for this example, we'll be focusing on just a few tables around issues. So if you go and see, our issue table, you'll see that there is data present in the issue tables. Turns out there are around 2.7K issues or rows that are probably normalized versions of the issues. And you have issues that are open, issues that are closed, all the details pertaining to a specific issue. And similarly, you would have like issue comments too, where for each issue, for each issue comment, you would have the ID of that comment, but then the foreign key referencing the original issue that lets you do the join across these data sets, and then the details that are actually important for building the RAG app, which is the body or the actual content of the issue comment. And we'll be using the body from the issue comment and the issue along with some other metadata to build the vectors on top of it. So yeah, you have this connector running, you have this syncing to the warehouse, and once every sync happens, we have a transformation set up. So or here, I've registered a transformation which creates a table called issue extended. Fivetran supports, bringing your own transformation by attaching a GitHub repository via code store, but it also supports just providing quick start data models. So quick starts are templates of these different transformations Fivetran has built. You can take a look at them on our repository. They're open source right now, but you can use either our quick start models or you can build your own models. In case you're curious on what a DBT model is just a SQL. It's just a SQL command. So I have some SQL commands written here in my GitHub repository, which is also open source. So you can check this out if you want. So one of the things I'm doing is I'm taking the different fields from the GitHub data, like, the issue ID, the issue number, the state of the issue, whether it's closed or open, the body, which is the actual content of the issue, along with some other metadata from other tables, like the user who created the issue or the user who the issue is assigned to. And I'm taking all of this, I'm just shoving it into like a very markdown like document. And the reason we're doing this is because this is like the most understandable form of data for the downstream, vector embedding models or large language models. They can understand these type of long text very well. So we sort of take the semi-structured data, we convert it into an unstructured document. And once you write the SQL query and you register it with Fivetran, Fivetran triggers it every time a sync runs. So the GitHub schema contains the source data in its rawest form possible with some very light massaging. And then the GitHub for RAG is the DBT model I registered. And you can see that you now have, the concatenated data present here. So you have your ID and then, the content, which is the column I created with all of this information. Let's see if I can show a more expanded version of this content. Python database, GitHub for yeah, okay. Workstar issue concatenate that. Okay. So we now have a more, more complete version of the issue. This is very similar to how, a human would look at or understand an issue on GitHub. You have the metadata, you have some metadata, you have the description of the issue as, the end user presented it. And then in case there are comments, you probably have some comments too. So I think this one has some comments, yeah. So there are a few comments here along with the issue that shows, all of the information about one particular object compressed into a single document. So once you have that, the data in that form, you can go back to Fivetran, you can go and set up a second stage pipeline that moves that data from, Snowflake or whatever data repository you're using to Zillus or Milvus, hosted anywhere you like. And all you need to do is, just set up this connector by plugging in your credentials. In the schema tab, you can choose which tables you want to vectorize and load to Milvus. So in my Snowflake instance, I had like a bunch of different tables, but I only want this table, the issue extended table, to be vectorized. So I just registered that here in the schema tab. And one thing that is important to note is that right now, Milvus or the Milvus connector requires a specific column to be present in the source table. And the column should be named, let's see what the name of that column is. Issue extended. Yeah, so these are the columns for the table, and Milvus connector specifically requires a column named original text to be present, and that is the column on which the vectors will be built. And you need to ensure that, while you're selecting your table on the Fivetran side, that table has that column present. And it's also, it's unhashed, it's unblocked, and it is of string type. There's another requirement too. So yeah, once you have, the second connector set up and it's syncing all of your modeled compressed GitHub data to Zillus, you're good to go. You have like a semantic search application ready. So I'm gonna shift to my Zillus instance here. And you can now see, a Zillus, a Milvus cluster hosted on Zillus. It's currently hosted on the GCP, but I think you can configure it to host on different clouds too. And I have a collection. This is the collection that was automatically created by Fivetran. It has the same schema as the table in Snowflake. It includes all of the columns that are present in the source GitHub entity. And you'll see that, there's all of this data that's present here. You have all the details about the issues, like the issue number, the issue's title, the issue's body, and things like that. And in case you want to do just vector search or just semantic search, you can do it like right here from the Zillus dashboard itself. You do need to generate a vector before you can search for it. And since we're using OpenAI's embedding model, I wrote like a simple script to generate that for me. So ask a question related to Tauhi. Let me ask what Does Tauhi support multiple GPUs? I remember reading that question earlier in the repository. So yeah, let's generate a vector for this. I'm using the OpenAI's embedding model, by the way, to generate this one. And I'm using text large. OpenAI supports 3 embedding models, ADA, small and large. I just use text large for this example, but if you need to save some costs, you can use like a smaller model if you're okay with some quality loss. Okay, I created the embedding. I'm gonna put it in here, and I can hit search. And now I have the top results relevant to my question, and you can see that my question, which was related to GPUs, is pulling out issues from these different from this data set that are related to, like, my question, which is like, does it support multiple graphics cards and things like that. My model also has a URL, so if you go, if you just go to that URL, you can see that you now have the original document that you want to look at. So this, this document talks about a user question. This issue talks about a user question where he's asking about whether he can support multiple GPUs with Tauhi or not. So yeah, now you have an end-to-end semantic search application built just by using a few clicks. You had to do very minimal coding. You had to do your data modeling yourself, but that's all you needed to do. And that's the most important piece of it, which is being able to figure out the right model for your downstream application, for the kind of application you're building, and not being logged into the data model you'd find from the source to be able to search across this data. And yeah, now the limits are endless. You can take this semantic search application, you can build a RAG application, you can build a chatbot, you can build a copilot, you can build something more agentic. Yeah, so many things you could do downstream once you have your data and this appropriate storage layer completely indexed to. So that is most of the work that we did to build the connector and enable the system to just demonstrate further capabilities of where the system could go. I built a chatbot using open source just frameworks like Streamlit and LangChain. So this chatbot, well, it takes in your Zillus credentials, where your Milvus is hosted and where Fivetran is syncing data to. So let's plug in the Zillus credentials. Yeah, so you need your endpoint. You need your API key. Very easy to copy from the Zillus website. You need your OpenAI key. So I have my OpenAI key here. Oh, by the way, once you plug in these credentials, this application automatically detects collections in your Zillus that are synced using Fivetran. So you don't really have to do more configuration to point to these sources. You can just come here and just select which source you want to, chat with. And I use the large model, not the small one, and the OpenAI key is here. I plug this in, and now I have my chat application ready to go. I can go and ask questions related to my, Tauhi repository. So let's say I ask one of the what question can I ask? Okay, so this is another example of a specific question that was asked by a Tauhi user. So he said, can clip model support local model path? Turns out, it can support local model path, and then you can support it by using this parameter. And it gives me this answer because I was able to find this information from the knowledge base that was provided. And it looks like, this information is present in one of these different tickets on GitHub. So let's go take a look at the most relevant one. So yeah, it seems like, the most relevant one is the user asking this question, how to use local model path. And then you can see that one of the repository maintainers responded saying that, it supports checkpoint path. So just through conversations from, around your product, you can ask specific questions about your product, and this just like alleviates the need for you to go and like look at different issues or look at different knowledge sources and be able to easily like search across your company data with just like a natural language interface. You can ask, another question if you're interested. Let's see what else is interesting from the repository. Ooh, okay, a question about memory leaks. Memory leaks are always interesting. How to fix, sorry, how to fix a memory leak in audio embedding pipeline. Also for this application, I've limited it to just 5 sources, because I'm using like one of the smaller GPT models, but you can, expand the number of sources you want the application to look at based on how powerful of a model you're using and, how much money you're willing to spend as well. So it looks like, I asked for just a how-to on fixing memory leaks, and it gave me a bunch of steps. It looked up different sources to understand those steps. And if you go take a look at the most relevant source, so maybe this is not completely related to memory leaks, but I think it picked up a few, things from here because of words like memory and things like that. So, memory, and then maybe something else is somewhere later in the thing. But oh yeah, this is the one I was looking for. So this is the issue that's actually relevant to the question being asked, where they're asking about the audio embedding pipeline and how to prevent memory leaks. And in the conversation, there are steps that can help you resolve this issue. And I was able to pick up on all of this information and provide a natural language response around it. So yeah, the possibilities of you building RAG apps or chat apps are endless once you have the data that you want to build the application on. And the latest Fivetran connector that syncs to Milvus just enables this much more seamlessly for businesses. If you wanna, if you go and build this pipeline yourself and you want to see if it's working, you can try the chat app yourself too. It's hosted at this URL, fivetran-rag.streamlit.app. You just have to go here, plug in your Zillus credentials, wherever you set up these Fivetran pipelines too. And once you have that set up, you should be able to immediately chat with your data. And also, navigate to the sources that these applications are citing as sources in the response. So yeah, that's it. That's it from me. I had a really great time working on this project. It was really interesting for me to see, just how easier it is now for companies to search across their data, including ourselves. I feel like Fivetran is one of the biggest power users of RAG apps internally, just due to the breadth of knowledge we have. And now with the Zillus integration and just with Milvus vector database, this just becomes like a whole lot easier for us and other companies to build such applications. So yeah, thank you so much, Jiang, for giving me this opportunity to work on this, and excited to see, how we expand this further.
Well, thank you so much, Abjad, for the great talk. And I'm really impressed by the demo at the end. And I think this technology will unlock a lot of interesting applications like chatbot, internal kind of knowledge base, and everything, powered by AI and search technologies. Well, we do have a few questions from the audience. The first one is, does Fivetran offer any free credits?
So Fivetran's free for the first 14 days, actually. So you can self-service sign up. You can try it out. I think the initial sync is free, and then you get like 14 days free for the entire account. Um, and then after that, I think there are chances you can get free credits if you talk to our sales team and, discuss what you're trying to build with Fivetran. But the first 14 days is just completely self-service. You come to Fivetran. I don't even know if you have to put a credit card. Like, maybe you don't even have to put a credit card. You can just like try it out and see if it fits your needs. Yeah.
Awesome. Sounds good. Give it a try, everybody. What is the second question? What is the chat app? I think the audience was asking for the link for the chat app.
Oh yeah, so the link is here. It's fivetran-zillis-drag.streamlit.app. So it's already deployed, so you can try it out. You just need to set up those pipelines first to be able to feed the data into this application downstream. So yeah, if you're already a Fivetran customer, it should be like very familiar to you. If not, you can just follow the steps I've described in this presentation to set up those pipelines.
Yeah, let's just have the actually I can just send the link in the chat. Okay, here we go. I think that's all the questions from the audience, and we're right on time. Well, thank you again, Abjad, for presenting this awesome integration and the fancy demo here. And for anyone interested in this, we have put the link in the chat about the integration, about the chat app that Abjad has just shown here. And also, if you are interested in learning more about this technology, feel free to reach out to our sales team through contact sales on Zillis or demo Fivetran, and we're happy to help you set up the the technology and get your business powered by AI and vector search. Well, thank you again, Abjad. I think that will be everything in this webinar. And thank you everybody for being here, with us. We hope that we can hear from you. And also please check the upcoming events link and resources. And welcome to our future webinars. Well, thanks everybody. Have a good day.
Thanks so much. Bye-bye.